So in last year, when you did polymers, you were only introduced to what are called addition polymers. The monomer was an unsaturated compound, so an alkene or an alkyne. The double bond broke, creating a single carbon-carbon link between them to create your monomer. You still need to know that stuff this year, but we're now introducing you to a new type of polymer called the condensation polymer. As the name suggests, when the polymer is made from the monomers, there is a small molecule, probably water, hence the word condensation, being given off as a waste product. You will find when we do this practically, usually the waste product is HCl though, a hydrogen chloride gas, because we can get better yields if we use an acyl chloride with an amine rather than using a carboxylic acid with an amine. However, I'm going to show you both ways today. So I'm going to just make up a polymer, and we're going to try and find the thing in it that tells us that it's a polyamide. And what you'll often see is a squiggly line at one end, which sort of is implying that it carries on this way for many, many units. Okay. Line there because I've run out of board. Okay, so this would be an example of a polyamide. We should be able to see where it starts repeating itself. Okay, and my hint to you is the first thing we're really looking for is an amide bond in this. Okay, so as we go from left to right, stop me when you think I've come across an amide bond. Stop. So in here, or further back, here. So this is an amide, this CONH. Okay, this is an amide bond. It's a secondary amide because the nitrogen is bound to how many carbons? 2. Okay, so this is our amide, particularly a secondary amide bond. Okay, or link. So that's what we're looking for. That's our functional group that says it's a polyamide because it's got amides in it. You can see another one here, another one here. That's probably the start of one, isn't it? That's probably the start of one. So we can see that starting to build. Okay, this time, stop me when you think it starts repeating itself. So I'm going to actually force it to be from here. So when it looks like this again. Okay, can you see that sort of NHCH26 NH bit? Stop me when you see that again. There, cool. Okay, so this thing here must be the monomer, as it were. Well, it's not. It's actually made from 2 different monomers. So you might remember with addition polymers, you only need 1 monomer. Usually with condensations, you have 2 that are different. Not always, but usually. So my big hint to you is to do it this way. We're actually going to find our first complete secondary amide bond. We've done that. I'm going to actually cut it in half on purpose. Okay, and I'm going to turn that into a square bracket. Now, I'm going to wait until I get back to this, and then I'm going to know that I've finished my repeating unit. So, same things we did before, but we're going to be further along. Okay, so keep going until I get it looking like this. So that is a mirror image of it. It's different, but that one looks to be the same, doesn't it? I cut this one in half, I do the same thing. I cut this one in half, and I turn it into a square bracket. Okay? This is what we call our repeating unit. It's not the monomer. Please be very careful, it's not the monomer. So our repeating unit means there must be lots and lots and lots and lots of them. In chemistry, how do we show lots and lots and lots of something? What do we put as a little subscript or prefix? N, lowercase n. So we do that. We put a little n there. This will carry on and on and on and on. Okay, there will be millions of them, literally, if not more. Okay, so we've got our repeating unit. We've already ticked off. We've identified the polyamide link. It is just a secondary amide bond. It's here, it's there, it's there. There's lots of them, so it's a polyamide. We now can find the repeating unit because we're finding something that starts copying itself. Okay. We now need to know what was it made from. And I put monomer and I was meant to put monomers there. Okay, and that's our next step. So what do you notice is in the middle of my repeating unit? What's in the very middle of it? The COON again, all right, which is an amide. So it's got an amide link in the middle of it. Okay, so what were we doing with the amide links before when we were doing work with this polymer? Splitting it in half. Hey, let's be consistent. Let's have the same pattern to what we're always doing. Let's break it in half. Okay? So I'm going to break it in half. You notice I'm using different coloured pens to try to get something a bit more sensible. Okay, and what I'm going to do is I'm going to draw each of those halves over here and over here. So I'm going to draw CO, CH28, CO. I know it's not a molecule because that carbon's only got how many bonds? 3. Okay, I know that. It's okay. I'm going to accept I've drawn it wrong at the moment. I'm going to fix that in a moment. Then I'm going to bring this one over here. Again, I know it's not correct because of why is that wrong? Nitrogen's only got 2 bonds, should have 3. Perfect. Okay. We said it's condensation. That means water or HCl. Okay? Now, let's assume that we do it, that was sensible when we do it from the acyl chloride. Okay? So let's say that we're going to assume that it's HCl. That was the product when this was made. N moles of HCl. Okay? Because that's how many of those bonds we've made. Okay, so do we think the Cl or the H is going to go on here, on a nitrogen? H. It makes sense, doesn't it? Right, because that makes an organic compound you've met before. What's this NH2 functional group? Amine. There's 2 of them, so can anyone guess what type of compound it is with 2 amines? Diamine. Brilliant. So this is a diamine. That's how you name it, not its type, sorry. So it's a diamine. It's got 2 amino groups in it. Okay? You would be expected to name this. You must be able to name this. Okay? How many carbons? 6. It's on each end, so which numbers are the amine groups on? 1 and 6. So it would be 1,6-diamino, if you want to go that way, because it's easier to name. 1,6-diamino hexane. Perfect. Okay, you would be expected to name this one. The nice thing is you're not expected to name this other one. Okay? So, you've told me to put the H's there. Well done. What's left in HCl? The chlorines. Okay? So, let's put the chlorines on each of these. Is this a functional group you've met before? Okay. It's an acyl chloride. There's 2 of them. Guess what? If that was called a diamine, this is called a diacyl chloride. Fantastic. Okay. So, you're not expected to name this one because they're too hard to name. It's called sebacoyl chloride if you really care. Yeah. You don't need to, but you need to know that it's a diacyl chloride. Okay. Now, other option was for these to be OHs. From H2O, H2O is HOH. H's are on that one to make diamine. The OHs would go here. If these were OHs instead, what would that be? Careful. a dicarboxylic acid. Well done. Okay? So you make them from something that's got the functional group on both ends. Notice the monomers have the functional group on both ends. There is a possibility, this is the next bit I want to get to, that it could be that one monomer has got both functional groups present. And this is what nature tends to do. And so this is where we have amino acids. So I'm going to cover that over just for now and show you what I mean. So as the name implies, which two functional groups do you think amino acids have? An amine and a carboxylic acid. Cool. So what we normally see them drawn as, this is where the biochemist in me comes through, is you normally see them drawn in a three-dimensional diagram. Okay, so you've got, now I'm going to get this back to front and I'll probably do the wrong enantiomer, but that's okay. Okay, and so you normally have it like this. And you'll see normally an R, and in this case the R is a particular functional group depending on the particular amino acid. You'll have an H, and not surprisingly you'll have an NH2 amino and an acid. I'm just going to put it like that. If I put two of these next to each other, and I do need an enzyme to make it happen fast enough, but if I put two of them together they can join together in a condensation reaction. So, we dash just means it's a different R group to that. They don't have to be the same. Okay, that's all. We can see in here there is a place where condensation can happen. So, H2O will be removed from this. And we end up with this thing here. Can we see our amide group in that? Okay, and here. So there's our secondary amide. When it's an amino acid, that secondary amide, or it's the start of building a polyamide, special polyamide, this has got a different name. Okay, biologists give it a different name, and so will we. It's called a peptide link. Then biologists get funny with their naming, so we'll allow them to be. And they go that this is made up from two amino acids, so it will be called a dipeptide. It's only got one peptide link in it, so that confuses the chemists, but we'll let them have it. Okay, we call this a dipeptide because it was made from two monomers. If it was made up of three monomers, we'd call it a tripeptide. Once we get to four, we'll call it a polypeptide. And polypeptides, once they have a three-dimensional shape, because the R groups start reacting or interacting with each other, once it gets a three-dimensional shape, we'll call it a protein. Okay? And then once you go beyond that, and you have the little things in the middle called cofactors and coenzymes and things like that, we'll call them enzymes. And hemoglobin is an example of it getting really complex. So, two amino acids, we call it a dipeptide.
What if you have two peptide links?
Right, so two peptide links would mean you started with three amino acids, so you'd call it a tripeptide. Good question though. Okay, so this is called, funnily enough, a dipeptide. So dipeptide has two monomers. It's not that it's got two peptide links, it's got two monomers. Okay, it's got, a peptide link holding two monomers together. And as you very well asked, if it had two peptide links, three monomers, so you'd have that being called a tripeptide. Okay, last thing I want to go through with you, and that will be kicked up and photographed later. The last thing I want to go through with you is what would happen if I hydrolyzed this. Okay, so I'll just quickly take a still of that.